So I'm happy to be back at BSides Oslo to present this research I did earlier this year. So it's hobby research into the Python ecosystem. So first off, the Python package index is used by millions of developers to distribute Python packages. So it works in this way. So you have the package maintainers that package and upload their packages to PyPI.org. And then you have package consumers that download and install the packages using a package manager like Pip or Poetry. I'm going to use requests as the example package throughout the presentation, but it's just an example and the tags are not specific to that package. So shout out to Stig and others at the hackerspace Hackeria for inspiring this work. And also the PyPI maintainers for how they manage the reports, and also feedback I got on how to present this. So the findings were reported to PyPI in June and July. There was one patch in June and another in August, and it was cleared for publication in August. I published 4 blog posts together with this talk earlier today because there's a lot of details I don't have time to go into. So first, let's look at the structure of PyPI packages. So you have a project, and then for each project you can have 0 or more releases, and for each release you can have 1 or more distributions. So distributions are just files, so you can have source distributions as tar gz or zip, and you can have binary distributions in the wheel format. So the first issue is that it was possible to do a denial of service on other projects uploading their packages. And the reason is that there's a global check to make sure that file names of distributions are unique across PyPI. And instead of checking the project name exactly, it only checks the prefix. So it was possible to make a prefix project to attack another project. So for requests, you can make req and then write the file that the request project might write in the future. And it's not that hard to guess like future major and minor releases. So this was quickly patched by the PyPI maintainers. Next, there's a new type of attack. At least I haven't seen it before, so please let me know if you have. So I call it distribution confusion, and the issue here is that you basically can make duplicate distributions. So there's the regular distributions I talked about before, and then you can make malicious variants that are equivalent. So let's look at how we can build an attack using that. So first we have the benign distribution with a regular file name. And then we're going to build a malicious variant by changing the first character to uppercase R. And this will target poetry. And then we're going to add the leading 0 to target Pip instead. And like this is just the most convenient way to get the lexicographical order correct, but there's other ways to manipulate the file name to get the proper ordering. So because these are equivalent, seen from the package managers, if you try to pin on like version or the platform or other tags, it will still select the malicious versions. But if you pin on the benign hash, that will work. But it will only work until you might add the malicious hashes. So I call this trust on every update, because if you use like a poetry update, the next time it fetches the hashes from the index, it will include the malicious hashes. So then it's still going to select the malicious ones. So the benign hash is just sort of safe until the next update. You might, of course, catch that in the code review, but it's not guaranteed. OK, so let's try a demo. Let's see. So when Poetry and Pip are deciding which package to fetch, they're going to pypi.org/simple/requests. And we can see that that gives us a list of install candidates with the file names and also the link to download the file. For the demo, I'm just going to run this locally. So on localhost, I'm serving 3 variants. So we have the benign one, this one. And then we have the capital R targeting Poetry, and the leading 0 targeting Pip. So if I first do, I pin on the version, and I pin on the benign hash. We expect to get the benign hash, so let's do that. So, and here we can see that the file that was actually fetched, it's the benign version. But if I now do pip install without pinning on any hash, but still pinning on the version, we see that it's the leading 0 malicious version that's selected. So let's move to Poetry. So first I'm going to do, I'm going to pin on the benign hash as before. And we can see that we are indeed getting the benign version. But if I then do Poetry update, it's fetching all the hashes again from the index. So now we see that the 2 malicious hashes are added to the set of trusted hashes in addition to the existing benign hash. And if I then do a Poetry install with this new set, I get the malicious variant with the capital R. So if So if you either don't have hashes or you have the malicious hashes in the trusted set, it will pick the malicious variants. Okay, so this is just one of the malicious distribution confusion sandwiches you can make. You could also target Poetry and Pip individually. This is kind of interesting because there's no other mechanism to target the package manager. Of course, all other package managers are going to fall into one of those 2 categories as well. You could also do the malicious variant in the middle of the sandwich. So then, like normal users would get the benign versions. And then you could have a malicious insider pinning on the malicious version. And also, like if you later delete the outer variants, which is possible, the malicious version would be chosen instead. So that takes us to also like you can have time varying sandwiches of different sizes to change the behavior over time. So like if you're doing a training or there's some reason you want to target in time, you could do it that way. So those who paid attention, I said that you can only have 1 source distribution per release, and I just did a demo with more than 1 source distribution per release. So we need bypasses. So the first bypass is that you could simply say, when uploading a target set, you can say that this is actually a binary distribution rather than a source distribution, and it would just work. So this was patched in August. And then the other way to do it, which is still not patched, is that you can give a different version in the metadata rather than the file name. And because the package managers just care about the file name, you'll still get this will still work. And you can have more than 1 source distribution per release. So while it's not patched, there are 2 open issues to fix this. So let's move over to a different attack called manifest confusion. So this was coined for the NBIM ecosystem this summer, and it was already publicly known to be an issue for PyPI as well. And it's basically that there's different ways to resolve the dependencies of a package. So in what I've done is just to look at which tools are using which sources and what might be the impact. So a lot of tools use the dependencies defined inside the distribution file, like pip tools, deps.dev, etc. So this is the recommended way from the PyPI maintainers. And then there's other tools that use the metadata API instead to fetch the dependencies, including Poetry, Snyk, and socket.dev. And the issue could, of course, be that if you're checking the dependencies in Snyk and then you're installing with pip, the results might differ. But it's actually more complicated than that, because you could also get different dependencies in each distribution, and there could be a lot of distributions. Say for NumPy now, you get more than 30 distributions. And also, like with distribution confusion, you could have even more ways to resolve a dependency. So this is just a screenshot showing that these 3 online tools that index all packages show different dependencies for the same package. So this is still up, and there's more details in the blog post. So deps.dev see URL lib3, while Snyk and socket.dev see charge set normalizer. Okay, so I talked about manifest confusion and distribution confusion. And this is resolution confusion is an attempt at an umbrella term. And again, if you've seen this before, let me know. But it's all the ways to resolve a package into something else than you expected. So of course we have dependency confusion, where the package is installed from the wrong repository. Manifest confusion, where there's multiple ways to resolve which dependency a package has. And then distribution confusion, where you might get the wrong distribution. So briefly on how I approached this research. So I was actually starting to implement a transparency log for PyPI. And then I had some assumptions that led to some bugs. And I started reading the PyPI source code. And it turned out that the allowed inputs were greater than what was needed to do a regular upload. So I wonder if this was possible to exploit. And then, of course, you can only have one source distribution got in the way, and I started to look for bypasses for that. So the 4 blog posts I released today is here. I've touched on most of these, but the second one on reproducibility in PyPI, that has a lot of other ways where you might get unexpected results with Python packages. And with that, I can take questions.
Anybody? Questions? Up top, on the balcony, downstairs? Yes. Excuse me.
Thank you. Now that you've seen that this possibility exists, have you had the opportunity to scan through PyPI, for example, to see if there are packages that could be vulnerable to this, do have these confusions in place, or other in the wild occurrences of this?
Yeah, so in general, because the file name rules have been so lax historically, there's a lot of garbage in the system. And for the most part, it looks like it might be accidental, but I haven't looked closely enough to know if it's accidental or not, those issues that are present. So that might be future research. But luckily, like, this is easy to scan for, right? It's easy to detect, much easier to detect than if a package is malicious.
Anybody else? Questions for Stian? Manifest confusion, distribution confusion. I like the rhymes. Where is the hand? Keep it up. Hello.
So the prerequisite that was listed, what does that mean and how hard is it to get it?
So that basically means you need to compromise a package to be able to publish as the maintainer. So it could also be, of course, that the maintainer turns evil, but you need to have permissions to actually publish packages, which should be a high bar. And basically, when you are pulling in a project, you are trusting that project to not do malicious stuff, right? So this is just one malicious thing you can do if you have those permissions.
Anybody else? Questions for Stian about these Python package distribution attack vectors?
Hi. I was wondering, you mentioned detection. Do you have any examples of good tools or ways or mechanisms to implement to detect these scenarios?
Yeah, as far as I know, nobody except the test code I have is doing that detection.